Okay, so in this video we're going to be solving quadratic functions by the quadratic formula. So this works with any quadratic function. Meaning, in the last video you seen if I couldn't factor it, I couldn't find x-intercepts, even though there might have been some. The quadratic formula works with any quadratic function. Okay, so the first thing you do to find solutions, root zeros, or x-intercepts, you're going to set it equal to 0. And then you're going to try to factor first. And when you try to factor, you see that there's a GCF of a 2, so pull a 2 out of everything. And then you're going to try to factor what's left. So when I try to factor that right there, remember that's set equal to 0, that will not factor. So I have to use the quadratic formula, which is x equals negative b plus or minus b squared minus 4ac over 2a. So I set it equal to 0, I tried to factor and it didn't work. So now the quadratic formula is your next option. One of two things can happen here. You can get your a, b, and c from the original function, or you can get it from this factored version. I always do the factored version because the numbers are smaller. Remember that number just transforms it by stretch or compression, makes it more narrow or wider. It does not change the x-intercepts. So now all you have to do is plug numbers in. So you're going to have x equals negative b plus or minus b squared minus 4ac. All of that's over 2a. Pause the video, make sure you know where those numbers are coming from. Now simplify that, so you'd have negative 1 plus or minus 1, that would be negative 8 times negative 5 would be 40 over 4. And you'd have negative 1 plus or minus the square root of 41 over 4. Now remember, this b squared minus 4ac is called a discriminant. When it is greater than 0, that means there's two solutions. So there's two solutions, negative 1 plus square root of 41 over 4 and negative 1 minus square root of 41 over 4. Now if you graph those, go back to the original. Now see, I put the 2 back in there and do the function. Turn that on so it shows. So there's your x-intercepts. Now if we pull the calculator up here, you can see that if I put in one of those numbers, so negative 1 plus the square root of 41. I'm going to hit enter there and then divide by 4. I get 1.35, which here is 1.35. So that's the approximate x-intercept of that graph. If I did the other one, and I did negative 1 minus the square root of 41, I want to get the other root, or x-intercept, or 0. Remember, there's a lot of words for that one thing. Is negative 1.85, which if I look back here, negative 1.85 is the root. So again, those roots are approximated here. The quadratic formula allows you to do that as exact numbers, which have a radical in them, which make them irrational. So I'm going to show you that right there I took out the 2. So I put in 2x squared plus x minus 5. This one right here, I put that in. As you can see, the x-intercepts did not change, but this parabola is less narrow than the top one because 4 is, A is 4 here and A is 2 here, so 4 is more narrow. So that blue one is going to be more narrow, but the x-intercepts did not change. That's why it doesn't matter if I take that 2 or not when I use my A, B, and C. So there's your 2 x-intercepts for that one. Now let's find the x-intercepts of this one. First rule is you're going to put 0 in for y, and then you're going to try to factor. There's no GCF there, and I can't factor that. We're just going to skip over trying because it won't work. When you're doing this by yourself, you do need to try to factor. Alright, now you plug stuff in. X equals negative, your B is -1, plus or minus B squared minus 4AC all over 2 times A. Should have wrote my A, B, and C here. Really suggest you do that when you're working along. Pause the video, make sure you understand those. Okay, now simplify. You would have 1 plus or minus. That would be 1. This would be -20 times 5 is -100 over 10. Now you have 1 plus or minus the square root of -99 over 10. Now you remember the discriminant, if that is less than 0, which that discriminant is, there's no solution. Excuse me. That's an imaginary number is what that is. So remember how to simplify that is, if I have a negative under the radical, it becomes an I on the outside, and then the square root of 99 would stay there. Remember, you can reduce the square root of 99 to the square root of 9 times the square root of 11. We've done this chapter 1, and there's a chart up on the wall to help you with this. The square root of 9 is 3, square root of 11 is right there. So this could become 1 plus or minus 3i square root of 11 over 10. This means no solutions, no x-intercepts. There were 2 here because I got a real number, or excuse me, there is a positive number under the discriminant. When there's a negative number under the discriminant, there's no real solutions. I'm going to graph that just to show you. Okay. Alright, so we can't even see the graph here. Let me see if I can get it to zoom out. I can't, but there it is. You can see, can't get it to zoom out, but here's the x-intercept, or the x-axis. There's no x-intercept because if I go up, you can see that right there's the parabola, and it's pointing up, so there's no way it could touch the x-axis. So that's why you have negative under the radical, because there's no x-intercepts.